Okay guys, I just wanted to make a quick video on the properties of logs, and then I'll make a video on expanding and condensing, which we use these properties to do. So the first property we talked about was the product property. And what this property says is, and all of these go both directions, right? You can go from here to here or this direction to this direction, right? It just depends on if we're expanding or if we're condensing. So if I look at log base b of m times n, that expands to log base b of m plus log base b of n. If you have two things multiplied together inside of a log, you can expand them and have addition between two separate logs. The other side of that is if you have two logs with the same base being added, you can multiply their arguments. And when I say argument, I'm talking about what's inside the log. So when you have two logs being added with the same base, you can condense them to a single log, multiplying what's in the log. So let's look at these two examples. The first one here, we have log base 5 of 2 x, y. We have three things multiplied together. So we can actually separate this into three separate logs, all with the base of 5. So log base 5 of 2 times x times y is going to be log base 5 of 2 plus log base 5 of x plus log base 5 of y. So each thing being multiplied together gets its own log. Okay. Then if I look at the second example here, we have two logs being added together. They do have the same base. It's base 10, right? This is a common log. So we are able to condense it. We can take what's in the logs and multiply them together. And since 2 times 7 can be simplified, I'm just going to go ahead and do it. Okay, so that is the product property. And we have the quotient property, which is fairly similar, but now it's with division and subtraction. Notice these are similar to our exponential properties because that's how we discovered these, right? If I have two things being divided within a log, I can separate them into subtraction. So m divided by n inside the log, they can each have their own log and be subtracted, right? Again, you can go the other direction where if you have two logs with the same base being subtracted, you can take what's in the logs, put them in a single log and divide them, with the first one being the numerator, the second one being the denominator. So if we take a look at this example, I have log base 2 of 6 divided by y. So what that is going to expand to is they're both going to have log base 2. It'll be log base 2 of the numerator minus log base 2 of the denominator. And just like we could with the product property, I can also condense using the quotient property. I can take two logs with the same base that are being subtracted and condense them into a single log. So this is going to be natural log, which is log base e. We're going to take the first is the numerator, and the second one is the denominator. And that is our condensed version of the quotient property. And then the last rule we are going to see with expanding and condensing is the power property of logs. Okay, and this is when you have an exponent on the argument of the log, you can bring it down out front and make it a coefficient. Or if you have a coefficient in front of a log, you can bring that up and make it the exponent. So if we look at this example, we have log base 6 of z to the 4th. I can bring that 4 down using the power property, and so that's the same as 4 times log base 6 of z. Okay, and just like I can bring an exponent down, if we look at this other example, I can also take a coefficient and bring it up to be an exponent. So this is the same thing as natural log of y plus 5 to the power of 6. It's not the entire log being raised to the power of 6, right? If I wanted to raise the whole log to the power of 6, I would do it like this. This is just saying that the argument is being raised to the power of 6, okay? And that is all on the properties that we are going to use to both expand and condense expressions.